All right, welcome back. We're going to continue on this journey of derivative with exponential functions. Today we're going to focus in on the chain rule. So we've done our power rule, we've done our product and our quotient. Today we're going to focus in on the chain. Recall the chain is used, for us mostly, when we have a quantity to an exponent. So we're going to go ahead and go into finding that derivative. So here, if I have the quotient rule, the chain rule, sorry, we're going to bring that exponent to the front, just like the product rule. Our e to the x plus 2 is going to stay the same. The inside stays the same. We're going to take the exponent and decrease it by 1, and we're going to multiply by the derivative of the inside. Derivative of e to the x plus 2 is e to the x. And that's really all we're going to be able to do with it. We can clean this up, maybe change the look of it a little bit. We can bring this e to the x, since it's a monomial, to the 4, which is also a monomial, and multiply those together. So we have 4 e to the x times e to the x plus 2 to the third. And that's going to be our first derivative. Here we have f of x equals x to the third plus 2 times e to the 2x. So I did this one for a reason. Here we have a quantity, but it doesn't have an exponent. So we don't have a chain rule here. We just have a product rule. We have x to the third plus 2 times e to the 2x. So we have x's in both terms, but we're multiplying those together. So to find the derivative here, we're going to take our first, which is x to the third plus 2, and then derivative of e to the 2x, which is going to be 2e to the 2x. And to that we're going to add our e to the 2x times the derivative of x to the third plus 2. Again, recall we don't have an exponent here. It's understood to be 1, so we don't have to do the chain rule. So we just have to find the derivative of that x to the third plus 2, which is 3x squared. I can go ahead now and clean up by taking out an e to the 2x. So I get e to the 2x times, here I'm going to multiply my 2 through, so I get 2x to the third plus 4 plus 3x squared. Again, I took out my e to the 2x's. And we can go ahead and put this in descending order if you want. It's not a big requirement. Kind of like to make it look nice. And there we go. And there's our first derivative. Alright, also derivative. Ooh, we have a nice ugly one. 2e to the x plus 1 over 2e to the x minus 1. So to find our derivative, here we have quotient rule. So we're going to take that 2e to the x minus 1, our denominator. Derivative of the numerator, derivative of 2e to the x plus 1 is 2e to the x, minus our high, which is 2e to the x plus 1. Derivative of the denominator, which is 2e to the x, all over our denominator squared. We can go ahead and clean up the numerator by factoring out a 2e to the x. So I have 2e to the x. I'm going to multiply that by my leftovers, which is 2e to the x minus 1. Distribute my negative, so I get a negative 2e to the x minus 1 as well. And that's over my 2e to the x minus 1 squared. Now I can go ahead and clean up my numerator here. My 2e to the x's are going to cancel. So I have negative 1 minus 1, which is negative 2. I'm going to put that up there. So negative 2 times that 2 outside gives me negative 4 e to the x over 2e to the x minus 1 squared. Alright. And then finally I have a little more complex exponent for my e. So if I think about my 2x all under a radical, I can think of that exponent. Again, we kind of like to think of that as g of x as my exponent. That's 2x to the 1/2. So here my chain rule is going to be in the exponent. So my derivative, I have my negative 2, and I got to find the derivative of this 2x to the 1/2. So g prime of x is going to be 1/2. My inside stays the same, decrease the exponent by 1, times the derivative of the inside. So I get 1/2 times 2x to the negative 1/2 times 2. So my 1/2 and my 2 will cancel, so I'm left with 2x to the negative 1/2. my 2x to the negative 1/2, I can make that a positive exponent by making it over 1. So we have 1 over 2x to the 1/2. So we'll multiply this by 1 over 2x quantity to the 1/2. And then e, again, the exponent of e will never change. And to go ahead and clean it up, we have negative 2 times 1 times that, so we can put it all on the numerator. That's a bad looking 2, isn't it? We'll leave it. So we have negative 2e to the square root of 2x over, and this 1/2, we could see it as a radical, so we could change that back to the square root of 2x if you wanted, or we could leave it as a fractional exponent. It's up to you. So that gives you an idea of where we could see some chain rules, and we saw a lot of different chain rule things there. We saw where we had just a basic chain rule, quantity to an exponent. We saw where we had that quantity not necessarily needing the chain rule. And then we also saw where we had to have the chain rule within the derivative of the exponent. So those are some cases where we could see. If you have questions, let me know. Good luck, enjoy, and happy finding those derivatives.